In this video, we're going to take a look at naming cis and trans isomers of alkenes. Remember, isomers means the same formula but different structures. In cis and trans, you may have heard these terms before, and actually they were used in chemistry for quite some time. And so I have two different structures here, and these are isomers of each other. They have the same formulas, but they have different structures. And on this first one here, you can see it looks like we've got a methyl group and a methyl group both above the double bond. And then down here, it looks like we've got a methyl group below the double bond. And here we have a methyl group above the double bond. And you might think to yourself, okay, so what? What's the difference here? Okay, well, as it turns out, double bonds don't rotate. They can't rotate, so that they're rigid. And so that means that this methyl group cannot rotate down here. And so these are two different structures. And your body would react to these two molecules differently. And you may have heard of like trans fats. Maybe not, but it has something to do with the structure like this. Okay. So now naming these, how do we name these two structures? Well, it's really not that big of a stretch from what we've done so far. And that is, we just find the longest carbon chain that has the double bond, and we count up the number of carbon atoms. So for example, this first one here, we've got 1, 2, 3, 4 carbon atoms, and this double bond's in the middle, so it doesn't matter if we go left or right or whatever. And so this one becomes butene. Butene, double bond. And let's just number this, go 1, 2, 3, 4. Okay, so this becomes 2 butene. And then to indicate that these two wings, I guess, of these two methyl groups are going on the same side of the double bond, that is to say above the double bond, we say that this is cis. So we say CIS, cis to butene. That's cis meaning that they're on the same side up there. Now, this molecule here, same number of carbon atoms. The double bond's in the middle there, so it doesn't matter which way we numbered it, but we can just go 1, 2, 3, 4 like this. And this would again be butene. Butene. And this one here, we've got the double bond there, so let's say that becomes 2 butene. And now we showed, to show that this methyl group is above the double bond, this one's below the double bond, we're going to call this one trans. Trans dash 2 butene. Okay, so that's just it, cis and trans. Whether or not these wings are above or on opposite sides, I guess the same side or opposite sides of the double bond. Now, what I'm going to try next here is I'm going to try throwing some names up and see if you can't draw the structures. Trans 3-hexane. And it might be easier to do this one first as opposed to this one, but here, stop the video and see if you can draw these, and then we'll come back and try it together.
A few minutes later.
Let's try drawing this one here. Now, I've got a double bond, E and E, and it's hexene, which tells me there's 6 carbons here. So 6 carbons, and after the third carbon, I've got my double bond. And then it's trans. All right, so I'm going to try drawing this one. I'm going to go C, there's 1, 2, and then here now my third carbon, 1, 2, 3 carbon, double bond, carbon, like this. So 1, 2, 3 carbons. And then it's going to be trans. So that means opposite sides here like this. So 4, 5, 6, like this. 1, 2, 3, 4, 5, 6. I can count. Really, I can. Okay, let's do that. All right, that looks better there. Now, I didn't put the hydrogens in, but we should do that. Okay, so let's see, this should be CH3, and this should be CH2. Okay, and here I should have a hydrogen, here a hydrogen, and then CH2, and then there should be a CH3 here. CH3 like that. Okay, so let's see, 1, 2, 3, 4, 5, 6 carbons, double bonds after the third carbon, and then it's trans. So on opposite sides, above and below the double bond. If you got that one, you pat yourself on the back and call home because you did pretty good there. That's all right. Okay, nice. Now let's try butene here. All right, so butene is going to be 4 carbon atoms. And we've got a double bond here. Oh boy, off of the first one. Okay, well let's do our double bond here. Okay, first carbon atom. All right, and then let's see, cis. So cis, I've got a chlorine, and then I've got the rest of it is butene here. All right, let's see, I've got a chlorine off of the first one there, and then I've got this double bond here. I'm just going to label this. I'm just going to go 1 and then 2 like this, just for right now, okay? And I know I've got a chlorine coming off of the first one here, so I'm just gonna go like this. And I'm just picking here at random. I'm just gonna go chlorine. Now, when I say random, I could put it above or I could put it below, and it doesn't matter, as long as after the double bond, I'm cis, which means it's going to be on the same side as the double bond. So that means it's going to have to be like this. Now, if I put that chlorine down here, then this line would have to come down this way to be cis. All right. So here's my 1 chloro and then butene. All right, so I need 4 carbon atoms, 1, 2, 3, 4. Okay, and I can throw in the rest of my hydrogens like this. Okay, so 1, 2, 3, 4, like that. Okay. All right. There's some good practice there. All right, I hope you did well on that. All right, very good. Cis and trans. Bye-bye.